So now I'd like to show you a specimen of impact breccia. When meteorites crush on the Earth, they create an impact crater, and if the meteorite is rather large, it makes a complex impact crater, which means that there is material that is ejected from the impact site, and it forms these rings around the impact site, and the center might actually bounce back and bring up some basement rock. And the energy during impact is so large that this material might actually melt, and therefore it makes a glass, and the deposit in the ring around the impact structure is often breccious and may contain glass. And here I've got a specimen from the Ries impact in Germany, in southern Germany, in Bavaria, and this impact is about 15 million years old, and this is a Suevite. It's a name that's derived from the local area, and in Swabia, therefore Suevite. And here we have this impact breccia. And what we see here immediately is these grey glassy areas, and that is impact glass. And then we have some of the more kind of dull buff looking material, and this is largely clay. Likely this was glassy as well at the time of formation. And then we have some fragments of rock, like this one here and this one here, that did not get melted but got caught up in the breccia deposit. Now, the impact of the Ries was so intense that there was glassy fragments thrown out, and they were transported for several hundred kilometers. There is the moldavites. These are tektites that are found in the current-day Czech Republic, and they are likely associated with the Ries impact, so they must have traveled for several hundred kilometers. Now, when we look for the restite material of the meteorite itself, we will find probably very little. There will be some atoms in the breccia from the original meteorite, but very few fragments have been detected there. And much of the meteorite might, if the impact is severely strong, might actually vaporize. So it's going to be very hard to find remnant materials of that in many of these impact structures.